So these are a slightly more straightforward application of the intermediate value theorem. What we're really doing is just showing that the theorem actually can be applied. You're actually not finding the zero, right? So in the last question, we were a little more focused on finding it. You still could here. What I would recommend is use a graph to kind of check if your approximation is realistic or not based on the picture, right? Because remember, a zero lines up with an x-intercept. So what you want to do, this is a continuous function, right? So you can say a is equal to 2, b is equal to 3, right? So we're looking on the interval 2, 3, right? This is a polynomial, which implies it's continuous, right? So that's a check mark, one of the things we were looking for. The other thing that we need to show is what's the value of a, f of a, and what's the value of f of b. In fact, let me write that up here, and we'll do the work to the side. Okay, so we need to find each of these values. So let's take a moment and do that. Let's find f of a, which is the same as what's f of 2. So 2 times 2 squared minus 7 times 2 plus 4. This is going to be 8 minus 14 plus 4. This gives you 10, negative 10. So this is like 8 minus 10. That's a negative 2, right? So f of a is negative 2. Remember, in this specific context, we're trying to show their signs are opposite. That essentially means that one lives above the x-axis, one lives below. Well, let me sketch it out formally in just a minute. Okay, so now we want to find f of b, and for us, b is equal to 3. So you've got 2 times 3 squared minus 7 times 3 plus 4. That's 2 times 9, so 18 minus 21 plus 4. 18 and 4 is 22, so this gives you 1. So this is negative, and this is positive, and together we're saying f of a is not equal to, I knew I was going to do that, is not equal to f of b. So a second check mark. So this right here and this right here, that tells us we can apply the intermediate value theorem. A lot of times I just write IVT, intermediate value theorem. Okay, so what this is essentially saying, and you bear with my rough sketch of what we're doing here. If we were to kind of sketch this out, we're looking at 2, 3, so our interval's over there. I'm going to exaggerate the drawings of it, so we'll call that 2, and we'll call that 3, right? So what we're claiming is somewhere on this interval, right, based on what we know about their outputs. Well, the output for 2 was negative 2, so somewhere down here. Again, my drawings are not to scale, but negative 2, so that's this point, right? And the output for 3 was at 1, so that's this point. So the idea is if this one's negative and that one's positive, or even the reverse, to get from one to the other for a polynomial, for a continuous function, it has to cross that x-axis at some point, which is where we get a real 0, right? So we can apply the intermediate value theorem, which means there exists, and shorthand for that is backwards E, a real 0 on our interval 2, 3, between those two values. Okay, now it could do a lot more than just this, right? We could have, it could go from here, it could go down, it could go way up, it could go down again, up, down, whatever, right? There could be a much more complicated path from this point to this point, but the idea is it's going to cross at least once, okay? If it crosses more than that, great, we get more than 1 0, but there's at least 1, and we can actually word that. We can say at least 1 real 0, okay?